Okay, but you will also have this page given to you. So here, this is to calculate the torsional shear stress, right? Torsional shear stress. So you don't just actually to save your time now. So instead of looking at part 2 of the code, you can look at the appendix, the last part of the exam paper. Then basically you need to know how to use these 3 equations. One is this one, calculate the torsional shear stress. Then limits of shear stress are also given to you. Make sure that this is, if this is greater than DT min, that means we need the torsional shear link. Okay? And then area of reinforcement here. ASV over SV is equal to T. 0.8 x1 y1, 0.95 fyb. So you don't need to remember. So you see what I'm saying? Just make sure that you get the units right. Understand? Okay, then here also the same thing. Alright? Okay. Just have to remember that this T normally is given to you in kilonewton meter. You convert it to Newton millimeter, multiplied by 10 to the 6. Okay? Alright, and final answers should be the unit should be millimeter, which is actually equal to millimeter square per millimeter. Understand? Okay? Alright. So I think this one is very easy to score points. Correct, right? Okay? So it's very easy. That's why I think the local students also want me to choose torsion rather than flat slab. Flat slab is harder. Okay? Alright, so this one. Is there any more questions on this one? If not, then we'll move on to another topic. Is that okay? Alright. Okay. Okay. I'm worried about Keisha. So she always not her head, then also always make the careless mistake. Okay, just make sure. Okay, alright. Okay. So I just try to make things simple. Okay. Then the other things is retaining walls. I want to make sure that you know how to get the walls and the moment. So 1/2 of the main thing is you need to actually sometimes you need to run some numbers, because when you run the numbers, then I can tell whether you get the units right. You see what I'm saying? Okay. Okay, let's just run some numbers. Normally I will give you the soil properties. So I give you the soil properties. The soil properties first is the height. The height of the soil, right? So normally I give you in meters. Okay, give you in meters. So let's say this is 4 meters. 4 meters. Okay. All right. Then so height is 4 meters. Then I give you the soil weight, gamma S. Gamma soil. Gamma soil. Let's say I give you 20 kilonewton per meter cube. So this is normally in kilonewton per meter cube. Okay. All right. Just like concrete normally we say it's 24 kilonewton per meter cube. So this is 20 kilonewton. And I need to give you then Ka. Okay, Ka. So Ka is 0.33, roughly, normally sometimes 1/3. Okay, I think instead of using 20, I use 80. Because later on it will be easier to calculate. Okay, all right. Then I give you the surcharge. Surcharge, let's say, is 10 kilonewton per meter square. Surcharge is an area load. Okay, all right. This one is the unit load is per meter cube. This is surcharge per meter square. All right. Per meter square. Then, so let's look at the so this one, based on this, you calculate the lateral soil pressure. Lateral soil pressure. Okay. So lateral soil pressure is triangular, right? Triangular. Okay, the deeper the pressure is more. Okay, all right. So the triangular, so like this. Starting from 0 to maximum. Okay, so first you need to get the maximum first. Okay, so let's say this. This is a P maximum, maximum pressure, small p, small p. Small p is what? Gamma times H. Okay, that means times H because it's linear, alright? It's linear to H. As H is increasing, the pressure also increasing. Okay? Alright, so this would give you gamma S, let's say 18 kilonewton per meter cube. So H here is 4 meter. Okay? Alright? Okay? So this gives you 72 kilonewton per meter square. Alright? Because meter cancel, right? So that's why meter square. Okay. Now, so what does that mean? That means this is actually means 72 kilonewton per meter. This is per meter width. Because we design based on per meter width. Okay, that means per meter width, this value is 72 kilonewton per meter. It starts from 0 to 72 kilonewton per meter. Understand? Yeah. Start from 0 to 72 kilonewton per meter. Okay, linear load and per meter width. Okay, so that's what each meter square it is about. Is meter per meter width. That means each meter width here, this one is 72 kilonewton per meter. Okay. Okay, so so this pressure, so this is the maximum pressure, right? So what is the average pressure? Average soil pressure. Let's say P average. Average soil pressure will be half of 0 plus 72, right? Right? Because you are increasing from 0 to 72, right? Okay? So average will be half of it, right? So that will be the other thing is I forgot to Tmax. I forgot the Ka. Okay, Ka. So I forgot the Ka. Ka here is 0.33, right? Alright, 0.33 actually roughly 1/3. Right? Okay, so this will be equal to 24. Okay, all right. So the average stress is 12. Okay, 12. So let me use the dashed line to represent the average stress. So I would say maybe is this. So the average stress. This is the average stress. Okay, that means this one is the same as this one. So if you cut this one, you put it, it becomes the average. Understand? So this average stress is 12 kilonewton per meter square, right? Per meter square is per meter width, right? So this average stress is 12. So this is 24. This is 24, right? Okay. So average is 12 kilonewton per meter width, right? Okay, understand? Okay, understand? So now you know how to, let's say this is a beam here. Now I have this average uniform. Let's say is 12 kilonewton per meter. So what is the total force? Total force will be 12 multiplied by 4, right? It will be 48, right? Alright. So here is the total force. Total force here will be 12 kilonewton per meter square multiplied by 4 meter. So this will be 48 kilonewton per meter. Right? Per meter. Correct? This per meter is what? Per meter width. That means each meter width here, my total load is 48 kilonewton. Understand? Yeah. Now, except that if this one is uniform, then the resultant load will be in the middle, right? But this is actually triangular, so the resultant load is 1/3 from the base. Understand? Yeah. So here. Okay, let me erase this one because I need to use this space. So that means this one is, here is 1/2, here is roughly 1/3 here. 1/3 here. 1/3 here, that means it's 1.33 meter. Okay? And this one is, so this total force is, average force is 12 kilonewton per meter width. Right? Then the moment, so you have this moment here. This moment, okay, due to the soil, is equal to this force, 12 kilonewton per meter width, multiplied by 1.33, right? Okay? So is 12 kilonewton per meter width multiplied by 1.33 meter. So what is the units? That means this is 16, right? 16, okay? Kilonewton meter per meter width. Okay, right? Okay. The units, if you cancel this meter, it will be kilonewton. But kilonewton is a force, right? But we are calculating the soil moment. So actually it should be kilonewton meter per meter width. Okay? Alright. Understand? Then this one is a service load, right? So I need to find the factor load, 1.4 m soil. Okay, understand? Yeah. So what is this value here? 1.4 m soil is 22.4. Is that right? 22.4 kilonewton meter per meter width. Okay, alright. So this is a soil. Now this one here, you can go through this exercise to get this one. Okay, you can also do 1/6 of Ka gamma H cube. So this formula I did not give, so you have to kind of remember it. If you cannot remember, then you go through this. Understand or not? Okay? Which one you prefer? You like to remember? You see, this is 1/6. Ka is 1/3, right? 0.33, 1/3, right? And gamma is 18 kilonewton per meter cube. And then H is what? H is 4 meter cube. Okay? So you can punch out the number and see whether you get 16 or not. Use the calculator. Where did I go wrong? So second now. So this is gamma H. So okay, average is 12 kilonewton per meter squared, right? So the force is, I have to multiply by another H. This is the maximum stress. This is the average stress. Now I need to do the force. The force is the average stress multiplied by H. Understand? Just now I said, yeah, let's say this is my average stress. So my force is my average stress, let's say P average. So this P must be equal to P average multiplied by this length. Length in this case is our H, right? So multiplied by another H. So is 12 kilonewton per meter square multiplied by another H is equal to, this is 12, this is 4, so 48 kilonewton. Okay, because this is 12 kilonewton per meter square, this is meter, so this is per meter. 48 kilonewton per meter width. Understand? Okay, so this should be 48 kilonewton per meter width, right? And this is 1.33. 1.33 is 60. So 64, right? Correct? So 64. So this is 64. So this is also 64, right? Understand? Because this one cancel, 4 to the cube, right? Okay. So your units is meter cube cancel out. So this is 64 kilonewton. Actually, it's kilonewton meter per meter. Okay. So I would encourage the students to remember this formula. Then you don't need to go through all this. Understand? Okay. Then after that, don't forget to apply the factor load. Okay, alright. So now just remember 16 Ka gamma H cube. Okay, 16 Ka gamma H cube. Unfortunately, maybe if I have put it in the test final exam paper, then you don't need to remember. But unfortunately, I overlooked that. Okay, I overlooked that. Understand? So when you get the final exam paper, quickly write it down on the paper. MS soil is 16 of Ka gamma H cube. Okay. The coefficient is 16. Okay. Ka, always remember there are 3 terms here. 1, 2, 3. This is H cube. Okay. Ka gamma. Understand? Alright, Keisha, can you memorize the formula? MS is equal to 16 multiplied by gamma H cube. U 16 K gamma H cube. Okay, alright, because it saves you a lot of time. Okay, alright. Now, so we have the moment due to the soil. We also have the moment due to the surcharge, right? Moment due to the surcharge, I think instead of 16, I think it's 1/2, right? Right? 16 Ka, okay? Then surcharge, H squared, okay? That means this Ka, this gamma H, that means here is H cube, right? Here is H squared, this is surcharge. Okay, understand? So K is 16, K is 1/2. Ka, okay? K is gamma, K is surcharge, K is H cube, H squared. Alright? Because why here is H squared? Because the surcharge is units is kilonewton per meter squared. This one, the gamma is kilonewton per meter cube. Okay? So meter square, H squared cancel out. Meter cube, H cube cancel out. Understand? Okay, So yeah, what is moment due to the surcharge? 1/2 of Ka surcharge H squared. Okay, alright, just remember this, because then you have the design moment ready. Okay, so after you do the surcharge, you multiply by 1.6. Okay, multiply by 1.6. So get this one correct. Okay, if you get this correct, if your design is not right, I mean, at least you can still, let's say, get 8 out of 25 marks. Just memorize the formula. Okay, all right. 1/6 of Ka gamma H cube. 1/2 of Ka surcharge H squared. Okay, and do not forget the load factor. Okay. So once you have the design moment, then you just go through the design. Remember the procedure, right? Okay, So here, MS soil is 1/6 of K. Gamma is the weight of the soil, HQ. Then you do the 1.4 M soil. Okay? So then after that you do the M surcharge equal to 1 R KA surcharge H square. Okay? Alright. So, okay. And then you do the 1.6 M surcharge. Okay? Alright. So the total ultimate moment is equal to 1.4 M soil plus 1.6 M surcharge. Understand? Okay? So this unit should be kilonewton meter per meter width. Understand? Okay, So 64. Okay, 1.464 is 1.4 times 64 is 89.6, right? So 89.6 kilonewton. And how about this one? This one is equal to 1/2. Okay, is 1/3. Surcharge is surcharge is 10, let's say, right? 10 kilonewton per meter square. So here is 4 meter square, right? So what is this value? 610. Okay, 4 times 4 multiplied by 10 divided by 26.67, right? 26.67 kilonewton. Actually, it's meter square cancel out, right? But then we write as kilonewton meter per meter width. Okay, understand? So now is 1.6 M surcharge is equal to 1.6 times 26.67, which is 42.67 kilonewton meter per meter width. Okay, so 89.6 and 42.67. So here is 89.6 plus 42.67, right? 67. So here you have 89.6 plus 42.67. So that gives you 132.27 kilonewton meter per meter. Okay, so each meter width you need to design for this moment. Okay? Okay. Okay. So then how do you calculate? So here you have the moment. So now you need to design for the reinforcement. So design for vertical reinforcement. So design for vertical reinforcement. First you have the MU already, right? Divided by BD square over FCU. Okay? So this is actually we call K. K is equal to this actually is given in the code. So this three equations are given in the code. You know, right? Correct. So here, in this case, is 132.27 kilonewton meter per meter wave. So B is a width here, okay, which is 1000 millimeter per meter. 1 meter width is 1000 millimeter, right? Okay, so that's why. And D here depend. D normally I'll give it to you. Okay, let's say this is let's say is 350. Let's say D. Okay, let's say the thickness is 400. The D is 300 something. So let's say this is 350 millimeter square. F of CU, let's say is 30 MPa. MPa is Newton per millimeter square. Okay, alright. So here. This thickness here, let's say is 400, right? Okay, we have this moment here, and that is why we have the rebar is going to be like this. Okay, so the rebar is going to be like this. Okay, right? So D is from here to here, which is less than 400. So I give it, let's say 300. Understand? D is the effective depth. Okay, all right. Yeah. So so here I should give you also the wall properties. So the wall will be the thickness. Let's say 400 millimeter. D is 350 millimeter, and FCU is 30 MPa, which is Newton per meter square. Understand? So this is the data will be given to you, but it's given to you in sentences. So you need to kind of summarize it, like soil properties or surcharge wall, right? Then get your ultimate moment is 1.4 M soil, 1.6 surcharge. M soil is 1/6 of K gamma H cubed, and this is 1/2 of KS H squared. Okay. My only concern is you switch. You understand? Always remember this is gamma H cubed. This is SH squared. Okay? Gamma H cubed, SH squared. This is 1/6 K A, 1/2 K. Okay? Maybe you memorize it like this. 1/6 Ka, 1/2 Ka. Gamma H cubed, SH squared. Maybe it's easier. Okay? Alright. Then after that, you go through and get the AS. Understand? Yeah? You want to go through now? So, first is these steps, right? Okay? Okay. Second step is, so this is the first step. Second step is to calculate the Z over D. Okay? Z is the lever arm, right? Lever arm is equal to 0.90 plus square root of 0.25 minus K divided by 0.90. So this formula is in the code, right? And then third is AS. Okay, AS is equal to M ultimate divided by Z. Here you get Z over D, right? So you can calculate. So after K, you put into here, you calculate this ratio, then multiply by d, you get the z. Then here you 0.95 f sub y. Okay, so why don't you now go through it and see whether you what's the value that you get. Okay. Remember, this is 350 d squared. D squared, is d squared. This kilonewton meter, you have to convert it to 10 to the 6 Newton per millimeter. Okay. Convert this to 10 to the 6 Newton millimeter. This meter width cancel. Millimeter square cancel. Here Newton cancel. So millimeter cancel. So this is actually not dimension. Okay. Why don't you do it first? I give you, let's say, 10 minutes. Okay. I'll go and have a drink and then I'll come back.